vectors. In the diagram, we have a cuboid. OA is 3 units, so just label everything so it's clear. OA is 3, OC is 2, so OC is 2, and OD is 2, so OD is 2. IJK direction according to the arrow. M is the midpoint of EF. Find the position factor of M. So to get to M, to get from O to M, we can go through A and then E and then M. There are many ways to do this. So if we do it this way, from O to A, we are going 3 units in the I direction, so we say it's 3I. Okay, so it's 3I, and from A to E, we are going, this is 2, so 2 units in the J direction, so positive 2J. And from M to E, well, because this is 2 and this is the midpoint, it's gotta be 1 then here. So 1 unit in the K direction, so that's just 1K or simply K. So that's the position factor OM. Now for calculate the angle PAM. So to calculate the angle PAM, just draw like this PAM. We're looking for the angle theta. The point P is 1, 1, 2. The point M from the previous part 3, 2, 1. The point A, just read here. So the point A is just 3I. So 3I means 300. So we have the coordinates PAM. Now be careful with the arrow direction here. If you are looking for the angle theta here, you have to use the direction from A to M, from A to P, or both towards A. So just use from A, from A. So this means we need the factor AM and AP. Now if you look at the MF19 formula, we have this factors formula. If you rearrange, so from A dot B, this is A dot B dot product, you just move this, so you divide, you get A dot B divided by magnitude of A, magnitude of B. Okay, so this is actually A dot B, magnitude of A, magnitude of B. It is from this formula. So that means we need the factor AP, factor AM, magnitude of AP, magnitude of AM. To find the factor AP, we do coordinates of P minus coordinates of A. So P is 1, 1, 2, A is 3, 0, 0, subtract 1 minus 3, 1 minus 0, 2 minus 0. We get the factor AP. To find the magnitude of the factor AP, we do square root of this squared. There's a square here, by the way. So squared, 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 we have 4, 1, 4, so that's 9. Square root of 9 is 3. So same thing with the AM. M minus A, the M is 3, 2, 1, the A is 3, 0, 0, subtract, we get 0, 2, 1, and the magnitude is 0 squared, 2 squared, 1 squared, and so on. So we have everything we need. The AP, the factor AP is minus 2, 1, 2. The factor AM is 0, 2, 1. The magnitude 3 root 5. Now when you do the dot product, just like this formula here, the dot product is minus 2 times 0, which is 0. 1 times 2, which is 2. And 2 times 1, which is 2. So this is the dot product. So we have 4 over 3 root 5. To find the theta, of course, we do inverse cos. Use a calculator in degrees, we get 53.4. Now the next part. Find the exact length of the perpendicular from P to the line passing through O and M. So first of all, we need to find the line equation, the factor equation of the line through O and M. Through O and M means you can use OO and OM. So the point O, which is the origin, which is the 0, 0, 0, and the line direction OM, and OM is just the position factor of M, which is 3, 2, 1. Okay, so this is the factor equation of the line. This is just 0, so just use 3 times lambda, 2 times lambda, 1 times lambda. So this is the line factor equation. Now the length of perpendicular from P to this line means we are looking for this distance. So to find this distance means to find the magnitude of the factor PQ. To find the magnitude of the factor PQ, we need the factor PQ. And to find the factor PQ, we need the coordinates of Q. So now we find the coordinates of Q. Now, because it's perpendicular, we have to use the dot product equals 0. The factor PQ is perpendicular to the line, therefore the factor PQ dot the line direction. So we use this factor from the line direction, not this factor because this is a point on the line and this is the line direction. So we use the line direction factor. Dot product means 3 lambda minus 1 times 3, we get this, and 2 lambda minus 1 times 2, we get this, and lambda minus 2 times 1, we get this. Now 9 plus 4 plus 1 is 14, and minus 3 minus 2 minus 2, that's minus 7, move to the right, plus 7, so lambda is 1/2. After we find lambda, we plug in, we get the value of PQ. So PQ is this factor. We know the lambda is 1/2. Replace the lambda with 1/2, 1/2, 1/2, and you use a calculator, you get 1/2, 0 minus 3/2. And now you find the magnitude, so square root of each component squared and add everything and take the square root, we get the perpendicular length from P to the line, or this is basically the shortest distance from the point to the line. So that's it. I'll see you again next time.